Hey learners, Jared here, and today we're going to introduce our next topic, kind of getting out of the classical mechanical physics unit, and we're going to get into something that has wide-ranging applications, dealing with everything from sound to light. We're going to look at waves. So first of all, we should discuss what is a wave? Well, it's a propagation or a transfer of energy from one location to another. Now, this energy can be potential energy, it can be electromagnetic energy like light, it can be sound. It's just traveling of energy from one location to the next. And anytime you're moving, you're going to have velocity, you're going to have speed associated with that. What affects the velocity of a wave, or how fast a wave can propagate or travel through a given material? Well, it's just that, the material itself, what the wave travels through, or what is called the medium. Now, different mediums have different velocities associated with them. Solids have a different speed of sound than gases, which have a different speed of sound than liquids. All of those different medias are going to affect the speed at which that wave can propagate through that material. Now, characteristics of the wave that you can observe in order to determine the velocity of the wave are the frequency of the wave, measured in hertz, which is just 1/seconds. It's how many oscillations or waves you see per second. The other property is wavelength. That is distance between two successive peaks or two successive troughs. What is the distance between those 2 points? That is your wavelength. To think about frequency, imagine you're standing in an ocean and you count how many waves crash into you per second. That is your frequency. Wavelength is how far apart those waves are. Velocity is how fast those waves are actually transversing space. All three of these things affect each other in order to give you the properties of that wave. Now, there's two types of waves that we're going to look at. Transverse waves, where the material that's actually carrying the wave transverses space. For instance, an ocean wave is a transverse wave. That water actually moves up and down. The other type of wave is a longitudinal wave. So it doesn't transverse space in a sense that it is a series of compressions and expansions. So sound is an example of a longitudinal wave. Sound is created by changes in pressure. That compression and expansion are what travels throughout the room to carry that sound, to propagate that wave. So think about any time you've ever made ripples in a lake or the ocean or pool or something like that. No matter how big the wave is, all of those waves travel the exact same speed. It doesn't matter how big a splash you make, those ripples are going to propagate out at the exact same speed. And that is because all of those ripples are traveling through the same medium. Now, that's not to say that they are the exact same wave, but their speed isn't going to change because they have the same medium. Now, the amplitude of the wave, or how far you have perturbed it from equilibrium, is going to determine how much energy there is in that wave. The amplitude of the wave does not affect the velocity, the wavelength, or the frequency. That would be kind of weird, because that would mean if you turn the volume up in your car stereo or something, you could change the frequency of the singer. And that would be weird, because then you would be changing the note that you hear because you wanted to hear it louder. And that's not how amplitude affects anything. Amplitude only determines the amount of energy that's going to carry with that wave. Increasing the volume is going to increase the pressure on your eardrums, and therefore increasing the volume of that sound, increasing the energy with that wave. So we've talked about how waves interact with their medium and how their medium determines their speed, but what happens when you have waves interacting with each other? Tune in next time and we'll talk about standing waves and how do waves interact with each other. And as always, keep learning.